Let me tell you one of my pet peeves, space solar power. Okay, the stupidest thing ever. It's like super obviously not going to work.
Space solar power could be demonstrated in 48 months with net energy in the hundreds of kilowatts.
Is space-based solar power the answer to our energy needs?
It could be deployed in 10 years.
Nothing you see here exists. These machines are not floating around above the Earth right now. Space-based solar power, the idea of building massive structures to orbit the Earth and beam energy back for our use is, let's be honest, a fringe concept. It's not business as usual. It doesn't exist. Elon Musk called it crazy. But others believe it offers a real hope of a zero-carbon future.
My name is John Mankins. I used to work for NASA. I am one of the world's leading experts in the topic of space solar power. The idea of harvesting sunlight in space and delivering it wirelessly to markets here on Earth. So in space, you would convert incoming sunlight, usually with photovoltaic cells, just like we do here on Earth, into electricity. That electricity would be converted into microwave energy transmitted from antennas and sent in a coherent beam to a targeted location on Earth where the microwaves would be converted back into electricity, and it would be distributed just like energy from an Earth-based PV array into the electrical grid at the receiver.
So can you just talk to me about the scale of this system that you're describing?
A typical transmitter in space that we're studying would involve a transmission of about 2,000 megawatts of electricity. That's enough for about 1 million homes. The transmitter for that would be about, a little bit more than a mile in radius, about 1.5 kilometers. And on the ground, 35,000 kilometers away, the receiver would be about 6 kilometers in diameter.
Now, a 6-kilometer radius for the receiver seems pretty large when you compare it to, say, central London or New York. But some of the largest solar farms in India and the US are already bigger than this.
That receiver on the ground, this rectifying antenna, is essentially an array of small dipole radio antennas, and it would look a lot like a metal cloth fence, and it would be essentially transparent to sunlight, about 15 or 20% filled with these little antenna elements, but other than that, it would be a transparent mesh.
So a mesh, a bit like a large fishing net? Is that what you mean?
A bit like a large fishing net, exactly, but with attached to the net approximately spaced just like your hand, the palm of your hand, with these little T-shaped antennas every 4 or 5 inches across this mesh.
Are there concerns about the safety of this to human life, to animal life?
One of the principal objectives in all of our studies here in the U.S. has been to look at ways to do wireless power transmission that are both affordable and safe. The peak intensity of the wireless power transmission at the center of the receiver is about 1/4 of full summer sun. And so it's far less intense than sunlight. Because the wavelength is long, about 12 centimeters, it's not capable of breaking electronic bonds, the bonds between the atoms that make up DNA, and therefore it cannot be carcinogenic.
How would we go about manufacturing something of this scale?
The particular concept that we're looking at is one that would be extremely modular in character. Each of them would be composed of a very large number of much smaller modular elements. Like thinking about building the Empire State Building out of children's blocks. Each block is quite small and quite inexpensive and mass-produced, but the overall model that this child might build might stand 3 or 4 or 5 feet tall. It could be huge.
The idea of wireless power has transfixed scientists and engineers for decades. It goes back to the dawn of the 20th century and Nikola Tesla, who wanted to develop wireless transmission of electricity in New York. but he couldn't secure the investment, so the project was abandoned. Could this also be the fate of today's space solar power projects? By 1977, NASA was claiming that space-based solar power could replace fossil fuels.
It's reliable, will probably last billions of years, and if you collect its energy from above the Earth's atmosphere in space, it can be done continuously. At the Goldstone Station in California, a tracking dish is being used to simulate an energy satellite in space. It sends an invisible beam of microwave energy to this rectenna, which represents a ground receiving station. The microwave is converted to electricity and powers the lights you see here. This is a small-scale demonstration of how a solar satellite would send its power back to Earth. By building huge solar satellites in space, NASA believes some of the sun's tremendous energy can be captured to lessen our dependence on more conventional fossil fuels.
But what if the first real-world use of space-based solar power was nothing to do with the zero-carbon revolution, but was really to serve the needs of the military? This is Boeing's X-37B. Controlled by the US Defense Department, it's a top-secret robotic spacecraft that looks like a tiny space shuttle. In May 2020, Orbital Test Vehicle 6 was launched to low Earth orbit aboard an Atlas V rocket. It was carrying a space-based solar power experiment designed by the US Naval Research Laboratory. The equipment transforms solar power into microwave energy, then studies transmitting that energy to Earth. It remains in orbit.
I'm Karen Jones. I work for the Aerospace Corporation. We are a federally funded research and development center, and I focus on game-changing technologies in the space sector.
Karen, talking about space-based solar power, can you tell me, who is it for?
I think as we start to see the rollout, who is it for will change over time. Initially, I think we're going to be looking at very discrete applications. Someone who is in a forward deployed military base understands the dire need for energy, and in fact, a lot of coalition deaths result from fuel transportation activities. So paying more for that type of energy makes sense in that situation. The same for very remote regions of the planet, the same for post-hurricane response, where a lot of the deaths were the result of not having power for nursing facilities and hospitals. So if you look at it, it's complementary in the scheme of what our energy needs might be in the future. There is utility scale solar power on the grid, and there is the power beaming agile type of solar power that you can provide for very discrete needs for different customer bases. It is possible, pushing out decades, that this could advance to the point of being competitive, but we don't know that yet.
Elon Musk's criticism of space-based solar was that the energy loss during conversion would never make it cost-effective compared to ground-based solar generation. I asked Karen and John what they thought of that argument.
Elon Musk talks about how there's really only about 2 times more sunlight in space than there is on the ground, and therefore it doesn't make any sense because you have to convert it. He is radically wrong in his numbers that he cites in that interview. It's an ad hoc thing. It was off the cuff. This is not a subject that he wants to talk about. He likes to talk about his programs, not somebody else's program or some other idea.
I know that Elon Musk referred to it as the stupidest idea ever. However, he said that in the context of directly competing in the exact same market for the same power source. I would compare that to a $200,000 Tesla Roadster versus a $14,000 Chevy Spark. They each have their consumers that appreciate what they're producing. The same applies here.
During our conversations, there was one country whose name came up every single time.
There is ongoing activity in China.
Well, China is expecting a prototype next year.
We know that the Chinese are working on this.
Everybody we spoke to mentioned China. So we asked a China space expert what the country's plans are for space-based solar power.
So at the moment we see that there is an experimental power plant being constructed in Chongqing in the southwest of China, and there have been low altitude tests of transmitting power via microwaves. It's hard to see if they are very serious about actually seeing this project, which would be completed by around the middle of the century. One thing they're looking at is something called a Long March 9, and that rocket would be comparable to, say, NASA's SLS or the Saturn V, which took the Apollo astronauts to the moon. So they would have to develop a reusable version of this. If you can't make an economical launch vehicle which you can reuse, then it's not going to be possible. There was a presentation by someone called Long Lihao, who was a Long March chief designer, and he's also involved in the committees looking into space-based solar power. His presentation in July of this year indicated plans for a reusable version of this Long March 9 and multiple launches, maybe getting something into low Earth orbit in 2025, something larger which will be capable of demonstrating maybe a megawatt of power capacity around 2030, and then moving on by 2050 having this kind of 10,000 ton space power plant in orbit. We don't get to see China's decision-making process and the budgeting like you do with the US with its space activities. But helpfully they have said, okay, by 2025 we're looking to have a demonstrator in low Earth orbit. That would be a good indication that they'll move on to more challenging higher orbits and higher levels of power generation.
But it's not just the space superpowers who are considering this technology. The UK government asked consultancy Fraser Nash to assess the viability of space-based solar power, and their report was published in September. It concluded that space-based solar power is technically feasible, economically competitive, and well aligned with UK government priorities. And the National Grid, which operates the UK's electricity network, doesn't rule it out either.
So for me, the potential is unlimited. One of the downfalls that we've seen over the years of wind and solar is that the wind doesn't always blow and the sun doesn't always shine when we need it to shine.
If we look at the UK's electricity patterns over a month, say in October this year, solar power is only generated during the daytime, and it varies a lot with the weather. Wind generates power day and night, but it's quite random and unpredictable. Gas is easily turned on and off, but you can see it's being used to fill in the gaps when the other energy sources are lower, and we emit CO2 every time we use it. Nuclear is practically a straight line. It's continuous and reliable and used as a baseload for all power generation. But nuclear power stations are hugely expensive, long-term projects which can face local opposition. Advocates of space solar power say that it could provide a similar pattern to that of nuclear without requiring or leaving behind radioactive materials. It would function day and night because a solar station in space would be far enough away to avoid the Earth's shadow.
When you have electricity on demand, 24 hours a day from space, you don't need to worry about that at all. So it's absolutely perfect for a base load.
National Grid is a company that has to make profit. It has to supply power, to its customers 24/7, but it has to do it profitably. Can you ever see space-based solar power being economical?
Absolutely. So it's estimated that the cost of space-based solar is going to drop to about 3 to 4 pence per kilowatt hour. So this could be half the cost of the electricity that we're providing today. So from a business model perspective, this is also incredible because you can sell this energy to other countries. You can point it anywhere. So if you don't need it in the UK, why don't you sell it to New Zealand? Sell it to Australia? Sell it to some place else around the world. You need to make money for this thing to be sustainable. We talk about sustainable and renewable. Sustainability means being able to make some money so you can continue to fund these types of initiatives.
Can it ever be commercially competitive?
Initially, it would be competitive for discrete markets. Terrestrial utility scale solar is very cheap now. In fact, in some places, it's actually more competitive than coal. So one way to view space-based solar power would be complementary to terrestrial solar. With some other types of technologies advancing, it is possible to make it more affordable and more commercial over time. We're not there yet.
All the core physics of a solar power satellite are in every single communication satellite that's ever been launched going back to the 1950s. It's all in the engineering and how you put them together and how you get the efficiencies up and the costs down.
Yeah, people think I'm mad. Because this has traditionally been seen as the domain of science fiction, there certainly is an unconscious bias, I would say, by a lot of people to say, space solar, what the heck are you thinking? A little bit of research will really bring it home, the unlimited possibilities of this and the benefit that this will bring to our environment, our society, and also commercially. And that's what we really focus on. But people, when I speak to them at a barbecue, they think I've probably had too much to drink. And it is a little bit out there, I will admit, but it's not that far out there. So I think we will see space-based solar playing a huge role in our energy ecosystem in the next 20 years. And people will think about all those mad scientists that came way before me, that were far more futuristic and intelligent about this. They will be proven right that this is actually doable.